All right, so we want to look at physics. Huh? Now, physics so far we've been looking at dimension analysis, okay, and I think one of these days I'll try to get some questions so that we can go through them together. All right. However, for today we're going to go into another topic in physics, which is vectors. Okay, so I want to look at vectors. So now let's look at the definition of a vector. Now, probably you are saying that this is a topic that you did in grade 10, but I want you to anticipate something new, and it's not something that is very difficult for you. Vectors is one of the simplest topics that you are going to obviously enjoy. So how do we define a vector? We say a vector is any quantity that has both magnitude and direction. All right. A vector is any what? Any quantity that has both magnitude and direction. Okay. Now, remember from the introductory part, we started looking at physics, and we said that physics is the study of physical quantities and how they relate with each other, their properties and how they relate with each other. And then we said that these physical quantities can be scalar quantities or vector quantities. So now we want to look at these vector quantities, all right? So now we are saying that a vector is a quantity, any quantity that has both magnitude and what? Direction, okay? So now we want to look at the magnitude and then we look at the direction of a vector, all right? So we're going to say magnitude and direction of a vector. Okay, magnitude and direction of a vector. So now what we want to look at under this. So let's say let A, okay, be any vector with x and y components, okay, as shown below. Okay, so let's look at a diagram that is going to represent a vector, okay. So we're looking at a diagram that is going to represent a vector. We have, let's say, the xy plane like that. So this is the x-axis, that is the y-axis. All right, and then we have a vector like that. So let's say this is the vector A, and then we have the x component of the vector and the y component. And then here we have the angle theta. Okay, so this vector A is making an angle theta with the horizontal, which is the x-axis. Okay, now the x part of this vector, or rather the part which is in the x-axis of the vector, is what is called the x component, and the part which is going up is what is called the y component. Okay, so now what we're saying is that this one down here from there up to there, okay, is the x component, which is represented as ax, okay, a subscript x. Then this one this side in the y direction, this is a y, okay, which is the what? Which is the y component of the vector. So the y component can also be written this side because you can see that this is making a rectangle. So you can see that you're making a rectangle. So this side, this direction, this point here, or rather this distance is the same as that distance there. So this ay we can equally put it here. We can write it there as ay. Okay. So now, if you notice, we're going to have a right-angled triangle. So we're looking at components. Probably I should have added that subtitle to what we are talking about right now. So we have components, magnitude, and direction of a vector. Okay. So now, let's look at the x component. The x component. So the x component of a vector is the one which is the component of the vector that is along the x-axis. Okay, this is the component of a vector along the x-axis. Okay, so in this case we can see that we're talking about ax. Okay, when we write ax, we're talking about what? The x component of the vector. Now we are using the letter A to represent any vector. Now remember, we said that we have vector quantities. Vector quantities can include things such as displacement, acceleration, force, and so on and so forth. All right. So in this case, we're just using the letter A to represent any particular vector that we can talk about. All right. So now, how can we find AX? I'm going to erase this diagram here and try to redraw it on top there. So what we have in our diagram was something like this. I'm trying to use different colors so that we can see clearly. So we had something like that. That is our A, and then we have the components. So this is AX because it's in along the x-axis. Then this is AY. Okay, this is AY because it's along the y-axis. Now you should remember that because this and this, they are parallel and they are the same because this is like a rectangle. So this distance from there to there is the same as the distance from there to there. So we can equally write AY on this other side like that. Okay, and we have our angle there. All right, the angle is right there, and then we can work it out. Okay, so what is AX? So how are we going to find AX now? Remember, this is our A, this is A, the distance from there to there, that is A, the distance from there to there, that is X, AX, then from there to there, that is AY. Now you can see that you're having a right angle triangle there, and then you have your angle there. So this is the hypotenuse. This is the hypotenuse, this is the opposite, and this one here is the what? The adjacent. Okay. So now remember that we say that cos theta. Okay, cos theta. If you remember from your trigonometry, cos theta is equal to adjacent divided by hypotenuse. Okay, so we're going to have cos theta equal to what is our adjacent? Our adjacent is AX, and then our hypotenuse is what? Is A. Okay, our hypotenuse is A. So now what are we going to have? So we are looking for the x component. Remember, we're looking for the x component of this vector. Okay, so we're looking for this. So in other words, we're going to make AX subject of what? The formula. So AX is going to be equal to A cos theta. Okay, so meaning that if you are given the magnitude of a particular vector and then you are given the angle of the vector with respect to the x-axis, then you're going to say that the x component of that vector is going to be equal to the magnitude of the whole vector multiplied by the cosine of the angle between that vector and the x-axis. Okay, then let's look at the y component. So this is the x component. Is there any question concerning the x component? I'll go through again. So remember there was that mnemonic that we used to use back then, SOHCAHTOA. All right, remember that mnemonic where this part, this is sine theta equal to opposite over hypotenuse. Then the part there, that is cos theta equal to adjacent over hypotenuse. Then tan theta is equal to opposite over adjacent. So remember that in particular mnemonic. This is going to be very, very important in our discussion right here. Okay, so it's not something that is very new. It's something that we have looked at several times in trigonometry. I think when you are in grade 9 as well as in grade 10. Okay, grade 12 rather. So it's a very simple topic. Okay. Okay, so let's continue. Let's look at the y component. All right, let's look at the y component of this vector. Okay, so remember our diagram. Our diagram was something like that. I shouldn't have erased it probably. So this was ax, and then we had ay right there, and then we had our angle right here. Okay, so now we want to look for the y component. Okay, the y component. So the y component is ay. All right, so this is the component. This is the component along the y what axis. Okay, so the y component of a vector is a component that is along the what, the y axis. Okay, so now how do we find this y component? So now remember, we're just looking at SOHCAHTOA. Okay, that mnemonic SOHCAHTOA. So we're going to use the sine. So it says sine theta is equal to opposite divided by the hypotenuse. All right, so sine theta, which is the angle that we have right there, is going to be equal to, what is the opposite? Our opposite is ay, which is our y component. So this is ay divided by the hypotenuse, which is a. All right, so we make ay subject to the formula. We're going to have ay is equal to a sine theta. So for you to be able to find the y component, you can use that. Now, I want to warn you against memorizing. Okay, I want to warn you against memorizing, because what you need to understand is the concept of trigonometry and not just to memorize. The reason why I've said that is these formulas are going to depend on the location, or rather where the angle is. For example, if the angle was here, let me write it in red, and then I'll use alpha and not theta. I'll use alpha. Okay. So imagine that is the angle that we had. All right. If that is the angle that we had, then it means that Remember our x component is obviously this one here, okay, this one. But remember, since that is a rectangle, or maybe let me try to draw a different diagram so that you understand properly what I'm talking about. So if we different diagram like that, and then we have our vector, which is vector A, we have vector A like that, and then we have an angle theta there instead of at the bottom where we had it in the previous example. All right. So in this case, what we're going to have is, if we extend from that point, we extend. Okay, we're going to see that. Remember, the component that is along the y-axis, that is the y component. This is AY, and then the one which is along the x-axis, this is going to be our AX. Okay, so as you can see, this is forming some rectangle. So remember, the opposite sides of a rectangle are equal. Okay, so meaning that this side is the same as that side. So saying that this is AX, and even that one there is AX. If this is AY here, that is AY. So that's what we are interested in. So this and that are also equal because it's forming a rectangle. Now, what I want you to notice is that in this case, our AX is this one here, which is going to correspond with the one at the bottom there, because that is rectangle and these two are parallel. Okay, so that is our AX. So in this case, AX is the one which is the opposite, unlike in the previous case where AY was the opposite. So I want you to get that one very clearly and never miss that point. Okay, so you need to understand the very little concept of trigonometry. All right, to say that you need to check where the angle is and see which one is the opposite and which one is the adjacent. Okay, in this one, in the first example that we had, AY was our opposite. In this case, AX is the opposite. So in other words, for us to find the x component, we are going to use sine and not cosine as we had in the previous example. For us to find, rather to calculate the y component, because the y component is in this case is the adjacent to the angle. So in this case, for us to find the y component, we are going to use cosine and not sine. Okay, so in this case, AY is going to be equal to A cos theta, as compared to this one where AY was equal to A sine theta. So you need to understand and see where is the angle. You don't just have to memorize those formulas and place them whenever you are solving a question. Otherwise, you're going to find yourself in problems when you write exams. Okay, so always make sure that you understand these little concepts. Okay, so that is how you calculate the component of a vector given the magnitude of the whole vector and the direction of the vector. So now let's look at how you can get the magnitude of the vector. First of all, before we move to magnitude, is there any question? Okay, so let's look at magnitude of a vector. So remember, we have this diagram there. All right. So what we have, remember, like I have said already, if this side was saying that this is the y component, so even this distance from there to there, we're saying that this is AY. Okay, and then that is our AX. So it is the same as we have a right angled triangle like that. That is a right angle. This is AX. That is AY. And we have an angle theta right there. And then this is our A. Okay. Now, remember, this is our vector itself. And then these are just components. Okay. So we want to find the magnitude of this vector. Now, to find the magnitude of the vector, okay, in other words, we want to find the size of the whole vector. So how do we do that? We say that the magnitude, now magnitude of a vector is denoted as, we say that magnitude, given that A equal to, rather A is any vector, okay, as shown in the diagram, okay, then the magnitude of the vector A can be calculated using the Pythagoras. Okay, I hope we all remember the Pythagoras theorem. The Pythagoras theorem. Okay, so it can be calculated using what? The Pythagoras theorem. Okay, I'm sure once I say that, we should even be able to know what we're talking about. Okay, because that is some theorem that is very, very simple and something that is that we've worked with several times. Okay, so let's look at how we can calculate the magnitude of a vector using Pythagoras theorem. So I'm going to erase that. I hope you've written already. All right. So we're going to find this the magnitude. So the magnitude A of the vector A. So magnitude, we use the modular symbol like that. So those two straight lines, and then you have the letter in between, is equal to, okay, the root of, remember we have AX, which is the X component, AX squared plus AY squared. Okay, now of course this is in units, whatever units. Now, why are we putting the word units? Because in this case, we're just using it in general, meaning that if it is force, then the units are going to be newtons. If it is displacement, then the units are going to be meters. Okay, and so on and so forth. All right. So now, where is this coming from? By the way, remember from Pythagoras theorem, if we have a triangle like this, if we have a triangle like this, where this is A, this is B, this is C, and then we'll say this side is side A, this is side B, this is side C, that A squared is equal to B squared plus C squared. And then we apply square root on both sides, we're going to get, which is the hypotenuse, is equal to what? Root of B squared plus C squared. So this is where we are. This is what we found there. I just went direct, but I've shown you this is where we're coming from. So this is the hypotenuse, which in this case is our A, and then we have our adjacent, which in this case is AX, and then we have the opposite, which is our square as AY. Okay, so this is what we have as a magnitude. So that is basically how you find the magnitude of a vector if you are given the components of that particular vector. So if you are given the components, you just square each of them, add them, and then find the square root of both of the sum of the squares of those components. Very simple and straightforward. Okay, is there any question before I proceed, before we look at the direction of the vector? So we want to look at direction of a vector. How do we find the direction now? The direction here, in this case, it's very simple, all right? So the direction is simply the angle, okay? In this case, it's simply the angle theta. The angle theta is the direction, okay? So in the case that we have there, the angle theta is what? The direction. Now, usually it is measured anti-clockwise. Okay, it is measured anti-clockwise with respect to the positive x-axis. Okay, so it is measured anti-clockwise with respect to the positive x-axis, meaning that you start from the positive x-axis and then you start moving in the anti-clockwise direction like that, so that you are going to have a positive angle. So if it is going anti-clockwise, then it is going to be a positive angle. If it is going anti-clockwise, if it is going clockwise, then it's going to be negative. So anti-clockwise, it's positive. Clockwise, it's negative. But we are not dealing with the negative angles here. We're going to look at them in trigonometry, in mathematics. Okay. So we measure them anti-clockwise with respect to the what? Positive x-axis. Now, how can we find the angle given the two components ax and ay? How do we find the direction of the vector if we are given the two components ax and ay? So very simple as well. We just go direct. We use remember I mentioned the mnemonic. So katoa. Okay, so we've already used the so part, we've used the ka part. Now we can use the what? The toa part, right? So how do we do that? Remember, we said that tan theta is equal to what? Adjacent, opposite over adjacent. Okay, so tan theta is going to be equal to what is the opposite? The opposite is ay, and then the adjacent is what? Ax. Okay, so I'm going to continue it from there. Therefore, we're going to say that we want to make theta subject to the formula because we are looking for the angle. So we say, therefore, theta, which is the direction, is equal to what? Tan inverse, then of what? Ay divided by ax. Okay, ay divided by ax. So when you do that, it means that you have calculated the what? The direction of the angle. Okay, the direction of the vector A. Okay, is that okay with everyone so far? Are we safe? Are we okay? Do we now know how to find the component, how to find the magnitude, and how to find the direction of a vector? Are we okay with that? Please make sure that if you have any questions, you can let me know, you can ask, and then we'll be able to respond to your questions. Okay. So I'm going to stop the recording here for now, and then we can continue with another one as part B of our lesson.